Hi, I'm Vandri Jooste, and I'll be presenting the ADAPT Center's Neural Machine Translation Systems for the workshop on Asian Translation 2020 document level translation task. So, just a short overview of what we've done. We participated in the document level business scene dialogue translation task, and for this, we only considered translating from Japanese to English. And then we started off by adding more sentences to the original training set. And then we also, from there, built three baseline machine translation systems using Marian NMT. And then finally, we set up four different scenarios to improve our best baseline system. And these scenarios were different fine tuning methods. So, just a bit more on the corpora we used. So, there we used the original BSD training set with 20,000 sentences, and then the JESC corpus with 2.8 million sentence pairs. We also used open subtitles with 2.2 million sentence pairs. And then finally, for one of the baselines, we also used the JW300 monolingual set containing 2.1 million sentences. And then with one of our fine tuning methods, we made use of the Common Crawl corpus where we mined 53,000 sentences to create a synthetic corpus. So for our baseline system setup, for the first baseline, we used the BSD, JSC, and Open Subtitles corpora. The byte pair encoding vocabulary size was set to 32,000. And then we used the same setup described by Siren et al. In their description of their neural MT systems for WMT 17. And then in the other two baselines, we made some changes to their original setup, which I will point out. So we used 8 transformer heads for baseline 1, and then the mini batch size for validation and the learning rate was kept the same as their setup. Then for baseline 2, we made use of the same corpora, except here the byte pair encoding vocabulary size was set to 6,000, and we only used 4 transformer heads. And as you can see, the mini batch size for validation is set to 32, and the learning rate has changed to 0.0005. And then finally, for baseline 3, we made use of the BSD, JAC, and Open Subtitles corpora once again, but to this we also added target side original synthetic corpus. So we built a model translating from English to Japanese, and then we translated the monolingual data, and then we had, or that's how we created our synthetic corpus. The byte pair encoding vocabulary size is also 6,000, and once again 4 transformer heads, and the mini batch size for validation and learning rate is the same as for baseline 2. Just so here on the performance, as you can see, baseline 2 performed the best out of our 3 baselines, and therefore from here on we only use different fine-tuning techniques on baseline 2. So for improving the best baseline system, I'll just describe the 4 different scenarios that we used. So in scenario 1, we fine-tuned our baseline system on in-domain data only, and this performed poorly compared to the other scenarios, which in the next slide I'll just show the scores that they got. And then for scenario 2, we made use of mixed fine-tuning, and the mixed set was our original training set, which was the BSD, Open Subtitles, and JAC corpora. And then we also oversampled the BSD training set 50 times and added this to that. And this actually got a 7.9% relative gain over the original baseline system. It also got the best blue score on the test set. So for scenario 3 then, we fine-tuned on out-of-domain data only this time, and the out-of-domain data was source-side original monolingual sentences, where we mine sentences that are similar in styles to the BSD's test set. We extracted terms in the test set that do not occur or rarely occur in the training set, and then we used this term list to mine sentences from the common crawl corpus, and then translated these sentences using our best baseline to create a synthetic corpus for fine-tuning. This corpus we called them the source-side original synthetic corpus. So for this, the RIBE score was better than that of scenario 2, even though the blue score wasn't as good. And then finally, in scenario 4, we once again made use of mixed fine-tuning, where this time the mixed set was the source original synthetic corpus, and then also the BSD corpus. And here, scenario 4 actually got the highest RIBE score, in contrast to the blue metric. So then just on the results, this was from the WAT evaluation site, the official results. So as you can see, their scenario 2 actually got the best blue score. So we also submitted this for human evaluation. And then, as you can see, scenarios 3 and 4 got better RIBE scores than scenario 2, and scenario 4 actually got the best RIBE score, even though the blue scores weren't as good. So just finally, in conclusion, we have shown that in the case of limited in-domain training data, both in-domain and out-of-domain data is useful for fine-tuning model parameters. And then making use of synthetic parallel data in training also greatly increased the performance of our machine translation systems. And then overall, we secured the 3rd position in the competition as per the rankings of the machine translation systems based on the human evaluation scores. And just for future work, we aim to exploit document level syntactic context in the fine-tuning step, and we also aim to explore increasing the training batch size at the fine-tuning step, as this may capture wider context during training. Thank you.